Here's a sorted array and a target sum, 10. Your job is to find two numbers in this array whose sum is exactly 10. Most versions of this problem ask you to return their indices, not just the values. One obvious way is to check every possible pair of numbers. You fix the first number, try it with all the others, then move to the next number, and repeat. Very quickly, the number of checks explodes. For n elements, that's on the order of n squared pairs. Brute force will eventually find the right pair, but it's slow and wasteful. But this array is sorted, and that changes everything. The smallest value lives at the left end, and the largest at the right end. Think of two explorers, starting at the edges, walking towards each other. If we add the leftmost value, 1, and the rightmost value, 15, their sum is 16, which is above the target 10. What if left moved one step to the right? It would land on a bigger number, and the sum would grow even larger. So when the sum is too big, moving the left pointer is the wrong direction. The only way to shrink the sum is to move the right pointer left to a smaller value. That gives us our first rule. If the current sum is greater than the target, slide the right pointer inward. The mirror case is simple too. If the sum is less than the target, we need a larger sum, so we move the left pointer right onto a bigger number. Let's see this logic in action, side by side with the code. We start with left at index 0 and right at the last index, so they point to the smallest and largest values. First pair, 1 plus 15, gives 16. That's bigger than 10. If we moved left to the right, it would land on 2, and the sum with 15 would jump to 17, even further above the target. So increasing the left value is the opposite of what we want. To reduce the sum, we move the right pointer left to the next smaller value. Now, right sits on 11. 1 plus 11 equals 12, which is still too big, so we move right inward again. Next, right reaches 8. 1 plus 8 is 9, and now the sum is too small. When the sum is below the target, we need a larger number on the left side, so we move the left pointer right. Left lands on 2, right is still on 8, and 2 plus 8 equals exactly 10. We've found a valid pair, so the algorithm returns the indices 1 and 4 and stops. The pattern is simple. Start with pointers at both ends, compare their sum to the target, and move the pointer that nudges the sum in the right direction. Each step moves one of the pointers inward, and they never move backwards. That gives a linear time complexity of O of n, with only constant extra space. This converging two-pointer trick relies on the array being sorted, so that moving left or right changes the sum in a predictable way. Once you're comfortable with this, you will see the same idea appear in 3-sum, 4-sum, and many other two-pointer problems.